Please welcome Ampere's Vice President of Products, Madhu Rangarajan.
All right, good morning, folks. I'm excited to be here. I've been in the server industry for over 23 years now, and I've not been more excited, and I've never had more fun than I'm having right now as part of Ampere, and there's a reason for that. And that's because we have done something revolutionary. We have created a cloud-native processor for the first time, and it's a processor that's specifically designed from the ground up for cloud-native workloads. And what we mean by that is these are containerized scale-out workloads deployed in a scale-out manner. And these are workloads in the cloud that are pretty common, things like web, memcache, scale-out databases, AI inference, transcoding, and so on. And on all of these workloads, we are delivering performance and efficiency with no compromise. And now, why does this matter? And you heard a few talks earlier talking about the carbon footprint and the effects of that. And data centers are contributing a significant portion of the global CO2 footprint now. And this continues to rise with the rapid growth in cloud. And one thing that really surprised me was that the emissions from data centers are actually higher than emissions even from some of the industries that you typically associate with carbon footprints, like aviation and shipping. So it's really critical for data center operators to take this into account as they plan their build-outs and navigate various government regulations that look to curb this footprint. And just as an example, in Ireland, data centers have been projected to use nearly 30% of the power in the country by 2029. And that's more power than all of the rural homes in Ireland combined. And what this is doing is it's forcing calls for moratoriums, and it's actually leading to delays where multiple major players have made decisions to delay build-outs because of the power shortage. And these regulations and challenges are only expected to continue to grow, and this is going to force cloud service providers to figure out how to deliver more with less. And on top of that, there are power shortages globally, and even more so in Europe, where power shortages are forcing really tough choices. Just one example, there's a neighborhood in East London with multiple data centers. There's also a critical shortage of housing there. And they're unable to build any more houses there because all of the power there has been taken up by the data centers. And in addition to that, power costs have actually increased by 200 to 300% since 2021 in Europe for obvious reasons. And this has a really large impact on the bottom line of cloud service providers, since, as many of you no doubt know, power represents a pretty large portion of the total cost of ownership of servers. And that is what makes this new paradigm of cloud-native computing, and specifically the cloud-native processors that Ampere is building, extremely critical. Every few decades, a new usage model comes along, and it drives a shift in the dominant software model. And that change in software happens first, and once the software reaches a tipping point, the hardware catches up. This has happened in the past. There was a transition from mainframe computers to a client-server model, which led in a transition from the old mainframe hardware to the heyday of the x86 hardware. But now there's a new transition that's already happened in software, and that is the cloud model, where your workloads are no longer monolithic. You no longer have a single mail server and a single file server and things like that. It's a cloud-native model where you have containers with all of the workloads I spoke about earlier deployed in a scale-out manner. And that's the software has already shifted to that model, and we are already at a tipping point where large portions of the software world have adopted this model, and now it is time for hardware to catch up. And this is where Ampere's revolutionary cloud-native processors come in. They can serve this usage model far more efficiently than legacy hardware, because the legacy hardware is still based on the previous client-server paradigm. And at the end of the day, cloud service providers want as much capacity as possible in a given footprint. And this new paradigm allows them to do that. This chart is busy. I won't dwell on it, but it's from luminaries in the computer architecture world, Drs. Hennessy and Patterson. Many of you have no doubt had courses with textbooks written by them in college. And what this shows is a period of time when we had Dennard scaling. We'd regularly get 2x performance on every core every 18 months, and the cost would go down. And life was good because everything would just be 2x faster without any refactoring. But those days ended sometime in the early 2000s, and the architectures had to make incremental shifts where they had to start going multi-core. They were still focused on some of the legacy metrics like, okay, single core performance and so on. But that's when the software world also started making a transition to the scale-out model, because the software developers quickly realized that, wait, I'm not getting 2x performance without doing anything. I actually need to refactor the software. And that's exactly what happened with the legacy, it's new software running on legacy hardware. But the new software doesn't care about the same metrics that the legacy hardware cared about, right? It's no longer about localized metrics like performance per core or even on a single server. What the cloud world cares about is metrics at an overall fleet level and a data center level. And it's time now for the hardware to catch up and adapt to this new world and optimize to those metrics. And this is where you enter Ampere's cloud-native architecture. What we've done is we've moved away from some of the legacy features that were largely driven from client. Things like turbo and hyperthreading introduce a lot of unpredictability in workload performance and performance jitter. So instead, what we did is we designed a large number of high-performance general-purpose cores that operate at a consistent frequency. And they also have single threads with dedicated resources, and they deliver consistent performance. And in addition to that, we are focused on general-purpose performance for the type of workloads I spoke about earlier, web, memcache, databases, and so on. So we don't add lots of power and area for dedicated acceleration features that take up a lot of power and area and only benefit certain small subsegments of the market. And by doing all of these things, what we can do is we can deliver twice the performance at half the power. And not only that, we can do that by pushing the utilization of your server to over 80 to 90% with linear scaling and performance without any performance jitter or any of the other artifacts you might see on the legacy processors. And what this allows us to do is it allows us to deliver a massive lead over competition on a key metric that matters to the cloud, performance per rack. Now, performance per rack is a really powerful metric because it encompasses three different things. It encompasses power efficiency, it encompasses real estate footprint, and it encompasses performance. And it speaks directly to how much capacity a cloud service provider can deliver with a constrained data center power and area footprint. It tells the cloud service provider how many customers they can serve and how much revenue they can generate within a given footprint. And as shown here, Ampere allows you to generate 2.5 times more performance per rack on most general purpose workloads versus the legacy x86 competition. And as you can see, right, we're not talking about incremental numbers here. We're really talking about a massive improvement here, and it speaks to the fact that we really are in a new era of computing. And this is true no matter what your rack budget is or what kind of data center you run, whether it's a large hyperscale data center or a small regional data center or even a very constrained edge location. In all of these cases, Ampere allows you to do a lot more with less power and less area. And deploying our architecture not only means that the planet will thank you, but so will your balance sheet as you look at the revolutionary performance, power, and area advantages that are delivered. And once again, right, if you look at these numbers, we're not talking about incrementally better numbers. These are really massive advantages that come with Ampere's cloud-native processors. But again, doing these revolutionary things, it's not us alone. It takes a community of you and OCP, and we are very proud of our association with OCP. We have contributed both of our reference systems so far to OCP. In 2021, we contributed our Mount Jade platform, which was for the Ampere Ultra processor. 2022, we contributed Mount Mitchell, which is for our upcoming Ampere 1 processor. In 2023, we joined the DCMHS work group. And we're really looking forward to our future contributions on things like OpenEdge, DCMHS, DCSCM, and so on, because all of these build upon the sustainability story I was talking about by modularizing the server and making the significant portions reusable. And we also continue to contribute to the open source firmware world, since all of this allows the ecosystem to adopt our technology much more easily, and more importantly, allows the ecosystem to innovate on top of our technology. And this allows the world to design with our revolutionary cloud-native processors. And what we like to say is less power is the new power. The paradigm has changed. The foundational model has changed from scale up to scale out. And shifting to this new type of hardware minimizes all of your carbon footprint. And I'm not talking just about the operating carbon footprint. There is also the embodied carbon footprint. There is all of the footprint that comes with building out the data centers, all of the concrete, all of the other non-server stuff that goes with your data center. It minimizes all of that footprint as well. And my call to action is to ask you all to look through all the resources we have available to begin your journey with us. There are a ton of resources. We do a lot of work to make sure that over 140 pieces of software are regressed every night, and the top of the tree is building. We have solution stacks available. We have links to our various partners, some of whom are in the audience. So all of those will help you get started on this journey with us. And do visit us and our partner booths as well. As you can see, we have our partner booths. We have the Ampere booth. We have our awesome colleagues like Sean Warley, who's going to give a couple of talks on his own. And he's also going to be talking with Peter Groth from HPE. Jayesh is going to he's going to get much deeper into one of our platforms called Mount Bonnell. And so it's all going to be exciting. And we were really looking forward to having all of you come to join this journey with us. And thank you so much, and appreciate all of your time, and thank you for listening to us.